When 25 to the power of 17 is multiplied by 6 to the power of 27, it creates a number ending with x zeros. What is the value of x? Okay, first things first, let's get one thing straight. You're not going to be able to just type this into your calculator, right? Your calculator does not have the space to handle these numbers. This is a very big number. And as the problem describes, it's a number that ends with a certain number of zeros, right? 0, 0, 0, 0. I don't know how many. That's what I'm trying to figure out. Now, on exponent problems in general, it's a good idea to break things down into primes. So let's start with 25. 25 is the same thing as 5 squared, right? So I can rewrite this as 5 squared to the power of 17. So I get 5 squared to the power of 17. There we go. And if I know my exponent rules, I can just say that this is 5 to the power of 34, because I multiply these two when I'm raising a power to a power. So that becomes 5 to the 34. Okay, and it's going to be that times whatever we get over here, 6 to the power of 27. Well, let's break 6 up. 6 can be broken up into 3 times 2 to the power of 27, right? 6 is the same as 3 times 2. I'm breaking it down into primes. And then if I use my exponent rules, distribute this in, this becomes 3 to the power of 27 times 2 to the power of 27. All right, and here is the big idea. What does it take to make a 0? And by that I mean if I add a 0 to a number, what am I doing? Well, I'm multiplying it by 10. So the number of zeros in this number is basically the number of tens that I can make in this number. So let's look at our building blocks here. We have 5 to the power of 34 times 3 to the power of 27 times 2 to the power of 27. If it's helpful, think of all of these just floating around in space. So there's a bunch of 5s floating around and a bunch of 3s floating around and a bunch of 2s floating around. What does it take to make a 10? Well, to make a 10, I need to match a 5 with a 2, right? 5 times 2 makes a 10. In other words, every time I multiply 5 times 2, I add a 0 to this number. So the number of zeros this big number has is going to be the number of pairs of 5 and 2 that I can make. Well, how many can I? I have 27 2s. I have 34 5s. So I can take 27 of the 2s and match them with 27 of the 5s to add 27 zeros to the end of this number.